Well, thanks for attending today's Lunch and Learn. We're going to be talking about DevOps today, which is a real hot concept that a lot of teams and a lot of engineering organizations are standing up. It's going to be me talking today, and also Lars has joined us. He's going to be drilling into some of the more technical ideas that we're going to be presenting. But this is really sort of a tour through how we got to DevOps, and then we'll talk about what exactly DevOps is and what the concept represents. All right. So about 13 years ago, which sounds like a long time, but about 13 years ago at your companies and definitely at my company, we were working as software engineers. We were working really closely with the hardware guys and the network guys. You know, every project we worked on together pretty much. There were projects that I worked on as a web developer where I was plugging Ethernet cables in and racking servers, and this was a really great relationship. We were best buddies, and we were the software guys, we were the hardware guys, and we were trying to work on these complex things together, and we got to have a lot of fun doing that. And then this person came along, the product person, and they started saying, wow, you guys are doing some pretty cool stuff. Let's make some money and do this at the same time. And I've got some really great ideas, and we said, all right, bring it on. And then we quickly found that the way that we were doing stuff at that time really couldn't hold up. The IE cracked down on traditional software development methods. They said, look, you guys want to be working with product? You want to play with product? You want to make that work? You're going to have to change things. So yeah, we were pretty much screwed, and we knew that based on product or on projects that we had gone through. Right, there were a lot of projects that that were just awful. I mean, at this time, this was the 2000s, 1999, 2000. You had Y2K, right? You had a lot of e-commerce, online venture type stuff going on, and these were death march projects, and we knew it. You know, we were horrified every time product came along and said, "Hey, I got an idea." But at least we were horrified together. We're still best friends. So, 12 years ago, 1 year sooner than 13 years ago, at a ski resort, far, far away, some of you might know which ski resort, we came up with the Agile Development Manifesto. And things came out of it like scrums and sprints, and product was a real big key, and team, and all these things, and lots of warm fuzzy, but also a lot of real effective concepts that really helped us to start delivering faster. Agile journals started saying, like, Agile's the way to go. You know, you get good quality, you get optimal costs, you get all this great stuff. Gartner started saying teams who successfully move to Agile do see productivity improvements. You know, they're more flexible. They can respond better to shifting requirements, and that's what those product people wanted to do. They wanted to innovate faster. And you even had the Agile, luminaries like Jeff Sutherland saying, making claims, real number claims like 75% gains over waterfall, real numbers, and standing behind those numbers, better satisfaction for their customers, better developer experiences. I mean, the developers were awesome now, right? They were kicking butt. They were huge, and product loved it. There was this romance brewing between the development team and product because they could give the product team what they wanted. But our ops guys, our hardware guys, really weren't brought along in that warm fuzzy model. They still had to worry about things like security, provisioning, installations, monitoring the stuff. They had to worry about things like power and cooling. They had to worry about connectivity. They had to worry about administration now that this thing's been developed and now I've got it. Right? And they had to worry about these two hipsters now that were hanging out all the time and telling them what to do. It really wasn't working out. So you ended up with this rift between development and operations, and it really is as big as the Grand Canyon in some companies. You've got operations people who do not talk to software people. You've got the software guys who've never even been in a meeting or talked on the phone with the operations guys that are actually looking at their software in production and responsible for making sure their software runs in production. At Carbonite, we're a little more communicative, but I've worked at places where I couldn't even touch a production server. I've worked, and to be honest, in my opinion, it was pretty awful. So we start looking into why that rift exists, and you ask why 5 times, and you really get down to the why. It's not because people are jerks or mean or don't want to work together. The real problem is the incentives. The incentives are that the development team is working with product to be innovative. They want change. And the operations team is incentivized to provide stability. 5 nines, 7 nines, 11 nines. Don't touch it. The nines are good. If you put something new in there, it's going to break. So you end up with this, this dichotomy. Fred is at the head of the table, though, and he's saying, look, guys, it really doesn't matter. We need to execute. We've got market, targets that we're trying to meet here. Figure this out. So people started figuring it out. They started looking in around 2009. You started hearing about the lean startup. Eric Ries was really pushing this continuous model, a lot of automation and things. A lot of the lean concepts, a lot of lean startup development came from this guy, Taiichi Ohno. He's the father of the Toyota production system, for those of you who are familiar with lean manufacturing. He's the one who started saying, look, you got to walk the floor. You got to see these things. You got to leverage machines. You don't want people standing there running machines. You want the machines to get so good that they can do it themselves. And then in 2010, this guy David Anderson wrote this awesome book called Kanban, and he took lean production characteristics and things and took it and put it into a development setting. And he ended up with this idea where you start looking at the value stream, right? You start looking at this delivery chain where things are being handed off, and you start putting some constraints to expose these things called bottlenecks. And you start saying, look, everything's piling up. We can't get to production. Why not? You start going through that process of asking why over and over and over again. And this is where the innovation really starts to come along, right? You start looking at that and you're saying, well, how do we fix this? Okay, let's innovate on our process. So what did we discover when we started looking at those bottlenecks? Well, we discovered that we had crappy planning, crappy testing, crappy deployments, crappy visibility, and crappy accountability. All that stuff. Seems like a lot. It is a lot. So how do we fix it? So we started coming up with some concepts, and these are the things that really are the principles that comprise DevOps. And Lars, you can start jumping in. The first thing that happened was Scooby got the seat back at the table. And that was like number one. All right, if we're going to solve these bottlenecks, we need to be partners again. Sorry, I've been running around with Velma all this time, but Scooby, come on, let's be friends. So really similar to extreme programming's on-site customer, which is where the person you're developing the software for is actually right next to you while you're developing the software. And to a lesser extent, Scrum's product owner proxy, which is really what a product owner is, he's the proxy for the customer. Which is less ideal than the on-site customer if you talk to the XP people, but active stakeholder participation brings the other people in the organization into that role. So we're really talking about your operations and your support personnel, people like that coming in to the development process. And really, like I said, what we're talking about is development, operations, support people, all working together closely on a regular basis. Regular basis, not every couple of months we get together and we talk about the state of things. It's a regular, recurring part of the process. It is a two-way street. Like I said, I've worked in some organizations where you barely talk to operations and support. And some of that is cultural, most of it's incentive, some of it is cultural. So it's a two-way street where the operations team and the support team also need to be willing to work closely and regularly with the development team. One of the principles that came along with these innovations was this concept of automated testing. You have to remember that automated testing for us kind of seems like, well, yeah, everybody does automated testing, don't they? No, not everybody does automated testing. So one of the key tenets of DevOps is that you test often and you test early. And you use unit tests to make sure the code's good. Most developers are used to writing unit tests because they're fast and I can run them whenever I want. But the integration test suites are really where the operational aspects and the environmental aspects come into play. The integration test suites are the things that say, your software is good on your machine, but it's also good when you wire it out to the actual resources that you'll be depending on. Along with automated testing came along concepts like test-driven development and behavior-driven development, which brings more of the product concept, the customer outcomes sort of things into the mix. You can run these automated tests before and after check-in, and that's what a lot of people are doing. And the automated testing part, a lot of people think about the after check-in piece, and we'll get to that. Automated testing, a key component of it is that there's got to be immediate resolution. You don't just run the test, see a failure, and check your stuff in, right? I mean, that just leads to instability. So one of the things that has to come along here is immediate resolution. And a lot of this gets into one of the major innovations in this particular realm, which is that automated testing becomes a piece of the acceptance criteria for delivery. You need to show that your stuff is passing your suite of tests as it is right now.
And I think one of the goals of this automated testing is to shorten the feedback loop, right? On whenever I commit something, if I introduce a bug in my commit, if we don't know that I wrote something until the code is released to production, it was going to be very hard for me to figure out what change introduced that bug, right? Because maybe if we are on a 2-month release cycle, then there can be hundreds or even thousands of commits to look through to track a bug. Whereas if we have automated testing, and as soon as I commit my stuff, hopefully there's a test that will find my bug, or at least indicate that there's something is wrong. So I can very quickly go back and look at my commit and see what I broke.
Integrated configuration management. We're just now starting to really look at integrated configuration management here at Carbonite. We're playing around a lot with Chef. Basically, the idea is that with an integrated configuration management solution, or even process in your development pipeline, what you're really talking about is you're saying, all right, we're thinking about the whole enterprise. As we're not just developing on a solution-specific silo with blinders on. We're really considering that this is something that needs to run anywhere. So here's some configuration that allows us to put it here, put it there, or set it up this way, or set it up that way. Like I said, it brings you around into this perspective where you're considering both the way the solution has to run and be configured, but also its native habitat where it's running, and how to configure it such that it works correctly in any environment that it gets dropped into. It teaches you to manage the full dependency range for your solution. Databases that you depend on, services that you depend on, network access, security, actual infrastructure. It teaches you to think about all these things. It also teaches you to understand your potential release impact, because in order to do your configuration management, you need to think about, if I'm dropping this new piece of technology in and it requires some database changes and things like that, you're starting to get a more holistic view of exactly what it is that's being changed. It's not just that line of code you just updated necessarily. There's all sorts of stuff that is supporting that as a foundation. You need to consider all those aspects. And this is another piece of acceptance criteria that's getting brought into the process, another gate that you've got to jump through, or I shouldn't even say it that way. It's another gate that we put in place to make sure that we're able to execute quickly. And both of those several concepts lead us to this idea of continuous integration. And that's where we're not just running tests at every check-in before we check it in or after we check it in. We're actually doing a full build of the solution at every check-in. We're actually running the integration tests where we depend on the dependencies, not just the unit tests. We're actually running the configuration management tool, or whatever it takes to configure this in an environment that is not simply my workstation, and maybe not even simply my build server. Maybe your continuous integration process deploys to a test server somewhere, and it runs through the configuration to make sure that your configuration is correctly too, and that your database connections are wiring up correctly, and all sorts of things. The validation, this idea of gates is coded into the continuous integration cycle. So you get into these things where all of a sudden you're running code and dependency analysis on your solutions before they come in. And you're running those automated test suites to make sure that everything's green when you make a change. And you know that it's not just green on your computer and you hit run tests on your computer. You know that it's actually been maybe deployed to a server in an environment that looks a little bit like the one that we've got in production. And you can actually confirm that you're mitigating your risk, you're delivering higher quality stuff, you're trying to ensure that nothing's breaking. Integrated deployment planning. So, planning continuously about the changes that you're making, but not just what are we going to change, but how are we going to get this into production. When I first got to Carbonite, we had, for the web team, we had these release meetings, and we still have release meetings. But we were meticulously going through a lot of aspects of the deployment process, which I thought was great. We were going through security concerns, we're going through network concerns, what has to change here, what has to change there. And it was never you can't change this, it was always, well, what needs to change? And the one problem that we had with the deployment meeting was that a lot of those things that, well, we're going to need to change this, like, oh, well, you should have told me that 2 weeks ago. So integrated deployment planning means during your story planning sessions or during your whiteboard sessions or anything, you're actually talking about deployment. You're actually talking about, well, what are we going to need to do to actually run this in production? What do our operations personnel, if they're not in the room, they should be in the room, but what do our operations personnel need to know about this deployment. Ideally, they're in the room helping plan out. Again, involving active stakeholders. So it develops this cross-team approach where you're considering more concerns. You have more concerns that you're trying to alleviate. You have more things that you're trying to, more gates that you're trying to get through. What you're really doing is you're trying to eliminate these silos of development and testing and production and all these artificial hoops we've really sort of put in place for us to jump through, when really with a cross-team approach we can answer a lot of these questions and have a lot of these concerns met more early on. What that actually allows us to do when we have this integrated deployment and everybody's on the same page, what it actually allows us to do is we actually get to increase our available release windows. We can actually say, okay, we've got an opportunity to do something here, we can make a change there. We have small changes that we're making, the tests are showing that they're good, the integration is happening the way we think it should. So we could actually, instead of once every 2 weeks, we could do once a week, we could do once a day, we could do 50 times a day maybe, depending on how these gates are set up and how on board and how on the same page everybody is. So production support. Production support's a touchy subject for a lot of organizations. I think it's absolutely required. I don't see any reason for the development team to not be functioning as some sort of report or support. Typically they're level 3 support. They're the ones who get called when all the other measures have been exhausted. They're the ones who get called at 2 a.m. on Saturday night because, the QA team has already run their battery of tests and everything still looks green and there's still something wrong with the system. It's a lot more than that though. It's not just call me at 2 a.m. I was out having fun, you guys are trying to figure it out. It's a lot more than that. It gets back to this integrated concept, this concept of having explicit responsibility about things being in production, about having an appreciation for what's running in operation, and having some learning opportunities to do something about that. Because you're now on the hook, you're actually not wanting to get a call on Saturday at 2 a.m. You're actually trying to think about what it is we're needing to put in place that ensures that this thing is stable. Sure, all the unit tests are passing, all the integration tests are passing. Why did we get that bug? You go through your assessments, you go through your 5 whys opportunities, and you start saying, well, we got a bug because the test suite is good, but we didn't focus on this particular case. We didn't know about that because there was a new set of infrastructure coming in, and we didn't talk about that in our planning meeting. You start seeing this stuff, and you start putting these stories together that really explain what's going on. Application monitoring is another big innovation that came out of this sort of investigation into the bottlenecks. Application monitoring is something that historically was done very reactively. You check the web trends report the next morning if you're lucky to have a machine that can process that much data in 24 hours. So, but what it means here is actively running monitors in solution, or running monitors on your solutions in production. And it actually goes beyond just your simple Nagios checks that say up, down. It encompasses all sorts of things. You're looking at operating systems. You're looking at application servers. You're looking at the communication services and the pathways between those things. You're looking at the end user's experience. We use Keynote here to tell us, oh, you can't get to the portal. We could be doing a lot more with Keynote to tell us about the user experience. And you're building in a ton of solution-specific instrumentation to give you visibility and insight into what's going on in production. And why are you doing this? Because you're on the hook for level 3 support and you have that production responsibility now. In a lot of places, like I said, you don't have that. And this is where the DevOps movement is really starting to gain a lot of momentum. Okay, well yeah, you guys are now on the hook too. You're getting a call too. Oh, well if I'm going to get a call, then I better build in some of this stuff so that I don't have to spend 3 hours tearing apart the code and guessing about what's going on. And everybody benefits from that. Integrated change management. We talked about integrated configuration management. Integrated change management, it sounds very similar. Again, we're talking about developing enterprise awareness here. We're talking about trying to consider not just what's going on with your solution and in all of its beauty, but we're talking about how this thing plays in the jungle with everything else. Netflix has their chaos monkey. It just walks around and turns stuff off, right? So, it gets people to think about, well, what happens if that thing is turned off that I depend on? And that's very important to running a tight operation. It teaches you to manage that full dependency range again. Talking about change management and thinking about changes ahead of time and having to work in a system where you have to define what it is you're changing. Very important to think about all of the possible dependencies. And it does teach you to think about this change impact. You know, you're going to change one line of code to you, but you're going to throw a cinder block in the pond in production. Okay, well, it was just one line of code. Well, you didn't really think about all of the impact that you were making on that. It looked like a pebble. It was a cinder block. And again, this is one of the innovations that gets tied into this acceptance criteria. These acceptance criteria all sort of work together.
So,
yes, go
yeah,
ahead.
okay.
Yep,
I mean,
jump in.
and that is, so these two things combined kind of become really powerful, right? If we have metrics that we collect over time, and we also collect every single change automatically that's made to production, for instance, then figuring out if the CPU usage suddenly spikes on the server, right? If we have a graph showing, okay, it started spiking at noon today, and we have a complete list of changes that were made to production, ideally somewhere we would have a change saying, okay, today at noon we released the new version of this piece of software. And that makes it very easy to identify these production issues, right? Otherwise you may have to look through a whole range of changes that could have caused this behavior.
Yeah. And change management doesn't just mean keeping track of the changes you're making or have made. It means keeping track of all the stuff that goes into the change. You know, how do you roll it back? What do I do? Is there a particular configuration step that I need to think about? When I was at Fidelity, I think the change management was a little over the top. But for any given change that we were making to production servers, you had a form you had to fill out. And one of the key things was, what's the rollback strategy? No one had ever asked me that before. And I was like, wow, I actually have to think about, if this doesn't work, what the rollback strategy is. And for us, it wasn't that hard. Well, you just reinstall the old version of the software, no big deal. But you still had to think about it. And that's a lot of what this is. It's a lot about putting this stuff into the front of your mind when you're considering changes. Automated dashboards sort of drives up from the application performance monitoring aspect, but really what we're talking about is business intelligence, specifically with development intelligence and operational intelligence. And that means thinking about stuff on the development front, like what Lars was just saying. You know, you're keeping change histories of code that's being edited. Who changed stuff? When did it change? How many changes do we make on it? What's the churn here in this solution? How many times did we release? Did we release today? Did we release yesterday? Those are the sorts of things that go into sort of the development side of things. Operational intelligence is where you get into runtime monitoring, characteristics. How available are we? What are the average transaction times? How much data do we transfer per transaction? How much data do we transfer per second? Start getting into a lot of these other counters that a lot of software developers, again, not being very involved with the operational aspects and production aspects of their solutions, a lot of them don't really see these types of things. You might run some load test scenarios on your workstation, but you don't see this information. This is really what DevOps is doing. They're saying, look, people can't fix these problems. We can't execute faster if we don't know how these things are running in production, because how can we make a valid design change to alter something in production if we don't know what's going on? So you need this level of intelligence. So you've got to figure out ways to capture and analyze this raw data. Some of this raw data is huge. You look at places like Facebook, and for us, it's huge when you start talking about the storage stuff. You look at Facebook and Twitter and these companies, and they've built huge Hadoop clusters running Hive and HBase, and they mine the data sets with Pig, and they do all these things. And it takes some investment, but the payoff can be huge. The payoff can be extremely valuable. You can display these things in automated dashboards everywhere. We should do this everywhere. There should be a dashboard everywhere I look, in my opinion. I should be able to see, you should go to the bathroom and, just like the restaurants where they've got the sports scores, you could go there and say, oh, look at that, there's our bandwidth, I mean, why not? Just put them everywhere. But let's think about this stuff. Let's think about production. It sounds like overload, but in reality it's reducing metrics overhead when you automate this stuff. You think about pulling together all this stuff manually, you think about running a daily report and cobbling together all the information. One, you've only got so much time. There's only so much that you can pull together. You've got one brain, there's only so much you can analyze. Once you start getting robots working for you and doing this stuff, the overhead of collecting more metrics or bigger sets of metrics or crunching through larger data sets, that's really where the overhead gets reduced. And like I was saying earlier, you can really start to provide this sort of real-time decision-making framework where you can actually look at the numbers and you can say, well, we just had this whiteboard debate, there's all this religion about, no, we should be doing services this way or services that way. And then all of a sudden you look at the data and you say, you know what? The service transaction is operating, that's like 1 millisecond. Like, why are we even talking about fixing that right now? Let's focus on where the actual problems are. This application spends 5 minutes cycling through that data set. Let's fix that instead. We'll change our design to work on that. So it gives you some actual data to work with instead of just waving hands and scribbling on whiteboards. And really, it sort of all leads up to this idea of continuous deployment. And this is sort of the panacea, the holy grail. A lot of people talk about this stuff. This is where Eric Ries really took his InView experience. He started saying, well, look, we make a change in our source code, and robots kick in, and gates are crossed all over the place, and bam, it's in production, and everybody's happy. Oh, well, if we're not happy, well, we'll figure out why, and we'll see what happened, and we'll encode that back in the robot, and we'll go forward. Continuous deployment, if you really drill into it, really is just an extension of continuous integration. It's like, okay, continuous integration is great. Where do we take it? Okay, you take it here. This is where you go. You take it from integrating and running tests to integrating, running tests, and deploying. You promote your code through any environments that it needs to go to. You jump from one sandbox to the next. We talk about this a lot with the CPET concept. You run automated validation after every one of those deployments. As you promote, your validation gets tighter and tighter and tighter because it needs to meet the acceptance criteria that's currently put in place by a real person. Right now, in any given delivery stream, except the people who have achieved this amazing thing, basically there's a real person at some point along the way who has to say, okay, go ahead, right? So the process of getting to continuous deployment, you don't just walk in one day, flip a big lever and go, continuous deployment. It's an iterative process. You promote and validate and promote and validate, and you keep doing that until you reach the real person who's going, no, sorry, I don't know. And you say, well, why? What does this mean? What makes you think yes? Well, it's got it lit up green on the unit test, but you didn't do any integration tests. Okay, boom. That's an acceptance criteria thing. All stories now have integration tests, and we're going to make the robot run the integration tests. Okay, now what do you think? Wow, the integration tests are lining up. Okay, cool, go ahead. And now person is out of the way, robot gets faster, and you're getting closer to this continuous deployment thing. I'm not saying people are in the way, like I just said. What I'm really saying is we're trying to make it so that they don't have to waste their time doing this. Because if we can get to what this means, then we can make a robot do it for them, and we can all go on doing much more interesting things.
Right, so kind of the reason to do this, or there are two primary reasons to do continuous deployment, right? One is, as software developers, we provide value by delivering software to our users. And if we can deliver that software faster, we provide more value sooner, right? So continuous deployment is really about getting the software in the hand of the user as soon as possible. The second...
And meeting all the concerns of your enterprise.
Right.
That's the key here.
Right. Right. And the second thing is kind of, again, back to reducing risk, right? Like with continuous integration, that if we have these 6 months release cycles, if we release something and it doesn't work for some reason, now we have to look through 6 months worth of stuff we've done to figure out why does it not work. Whereas if we release 5 times a day, and we have some automated way of identifying that something is wrong, we can immediately see, okay, this release we just did, there's something wrong. We have a couple of commits to look through and identify what could have gone wrong here. There is, I think the continuous deployment kind of originated at Flickr. At least there were some of the first to do it. You mentioned LnL as well. One thing Flickr really was big on was to have feature flags, right? So it may be that your specific feature that you're developing may not be ready for the customer yet, but we actually still want to deploy it to production. Maybe so we can test it on a small set of users, or just have it there running. Maybe a small part of the code can be tested with the rest of the code. And you kind of control whether your features are enabled or not using feature flags, right? And they can be either globally on or off, that my new feature is on now or it's off, or you can do kind of the canary releases and turn a feature on for a small number of users to kind of get a feel of, okay, does this new feature I'm about to deliver, actually, does it actually work in production?
And Flickr's not the only place doing that. Facebook has jumped on the feature toggle bandwagon, and actually HubSpot, I've just recently learned, has also gained a lot of value and benefit from using the feature flag concept.
We have a feature flag concept. It's not easy to use necessarily, but we have it.
Right.
Yeah. What would be nice is if we could figure out a consistent way of doing that across applications and solutions, and then I think that would be an inflection point for us, for as far as being able to deliver things a little bit more frequently and rapidly. So here we have DevOps. You finally combined the great stuff in development and the great stuff in operations, and everybody's working together again. And like I said, a lot of benefit, a lot of value, and a lot of happy people. Really what we're talking about is leveraging the pipeline and creating some economies of scale. We're talking about standardized processes, standardized approaches for configuration, standardized maybe even processes for developing code at some point. That's all up for a debate, I suppose. We're talking about repeatability. The release cycle always works like this because a robot does it. Okay, great. When humans do things, you do things a little different almost every time, unless you're really disciplined. You put a robot in place, he does the same thing every time. It's great. He just keeps doing it the way he does it. And if he does it wrong, well, you just tweak him a little bit, and then he does it right every time after that. It's like he doesn't have a brain or something. It's amazing. We're talking about getting some visibility and at an economy of scale, meaning that you're getting this across the board. You're getting a cross-cutting visibility across application tiers, across infrastructure, across product vertical slices. You get this visibility that comes along from all the instrumentation that's built in, from the automated dashboards. You can get a holistic view of what's happening. Something might be spiking over here because a change happened over there. Again, we get into this full range of dependencies, thinking about impact. And that leads into troubleshooting. All of a sudden, your visibility starts going crazy, and you're like, whoa, what's going on? Well, something's going on over here, okay? Well, jump into that source code right now and start figuring out what's going on, okay? We spent 7 hours tearing through the source code. We looked at every line of code. Everything looks good, and the tests are lighting up green in my machine, and da-da-da-da. Okay, you know what? The problem is there's something going on with the database over here, and it's not a code thing. The database had a job running, and it slowed down, and the system ground to a halt, and the latency went up over here. This is the kind of troubleshooting stuff that you get when you start looking at economies of scale across the board. And this is really what DevOps is bringing to the table. Organizational latency. This isn't performance of applications. What this is responsiveness for when we need to change, right? With economies of scale in place, you can start saying, all right, well, we need to scale up. This is sort of the cloud promise, right? You need to scale up? Okay, fine, we can scale up because all of our servers are the same when we do it this way. Boom, 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 boom. Okay, we need to change how we do something with our network gear? Okay, well, because all of our network switches are the same vendor or the same model or whatever, it's very easy for us to respond. And that's what we mean by organizational latency. We're improving that because our pipelines are tuned well. Really what we're talking about is you get this better communication. Your economy of scale on the communication front is everybody starts speaking the same language when it comes to development and running things in production. Everybody is aware of what the infrastructure looks like, of where solutions live, of what addresses are here and there. Everybody's got their own specialty, but everybody is at least aware, and the communication channels really start to flow a lot better. And that's what it's really about at the end of the day. It's about communication. And a lot of people are probably saying, well, DevOps is just the next thing. We've had Agile for so long. Well, you know what? Actually, in my opinion, and I found this graphic, and it's a little blurry because I blew it up, but this sums it up perfectly to me. Like I said, development and the business people, the product people, whoever, Agile development came along because of that. There was a problem there. There was a wall there. And the developers all were tired of the wall and things being thrown over the wall to them. So they went out to Snowbird and got together and came up with a, we're not going to take it anymore sort of thing. And boom, Agile development came out of that. DevOps is doing the same thing for the relationship between the development and the operations team. So in my opinion, it's not a replacement for Agile. I think Agile is a great methodology for working with your product people, the people that are looking for what the customers want and watching the market and try to see what needs to be built next. DevOps is handling the communication between the development teams who are responding very quickly and the operations guys who, until now, really were sort of left until the end. They left for when development was done. And I've been saying this for a while, you're not done when the code is checked in. You're done when your stuff is in production. And that means bridging this wall here. And that's why I'm such a fan of DevOps. Because really what we're talking about is making Fred happy, right? He's the one who's saying, guys, execute, this is what we want. We're all trying to make Fred happy, and he's the one who's coming up with these grand ideas that's trying to take places like ours to the next level. And so we're all on the hook for that, even the product people. We all have to come up with it, and now we're all friends again, and we're all happy, right? So that's DevOps, in my opinion.